Okay, we're looking at intersection of two lines, and we're looking at it in both 2 and 3 space, but 3 space is more the focus. So, what's the goal today? You need to use previous skills to find the solution with 2 lines, and you need to be able to describe the answer using words or picture. So, I'm going to give you the 4 possible outcomes when we're talking about 2 lines. So you already know, or most of you are saying, well, one of the possibilities with 2 lines is that we have a point of intersection. Point of intersection. So that means the 2 lines will cross at a particular point. So not exactly shocking anyone here. And the emphasis is that there's a point of solution, point of intersection. Second one, lines are coincident. Okay, which means that the exact same line. So I'm just going to draw one infinitely long line longer than the other. So now they're coincident, which means there's an infinite number of solutions. The third one, lines are parallel. So all of these match up with what you already know from your grade 10 experiences with systems of equations. So the 2 lines are parallel. And here is the only additional situation in 3 space. Lines are what we call skew. And what that means is that they don't intersect, so they're very, very similar to 3, but they're not parallel. So we end up with lines that look like this, and then try to draw this properly in 3 space. It's so easy drawing 3 space with a 2-dimensional board. So let's draw the line this way, and then I'll just draw it with a gap to show that it's underneath. Okay, so they don't meet. Other way you can look at it, maybe, I don't know if this is much better, passes underneath. So lines are skew, so they are not parallel. Not parallel. So it's like point number 3. And do not cross. All right, so those are the 4 possible outcomes here. So what I want to do is I want you to be able to take equations. I want you to be able to take equations given in whatever form, vector, parametric, symmetric, or standard, and I want you to be able to tell me or determine what situation are we dealing with here. So, starting with a 2D situation, determine the point of intersection for the following lines or systems of equations. So, how can you handle this? Well, because it's 2D, this is going to look a lot like grade 9 or grade 10 with the substitution. So the first one, and I'm going to work directly down here. So the first equation, what information do I take from that? I know that x is equal to 1 plus 3t. I know that y is equal to 7 plus 7t. And I'm going to put a subscript 1 to indicate that's from equation number 1. So this is equation 1. This is going to be equation number 2. And I don't like the format. I'm going to change it to the same format as what I have here, which is parametric, really. So x2 equals 4 plus m. Remember, I can't use t again. I got to pick a different variable. And y2 equals, let's see here, 1 minus 2m. So there we go. If we have an intersection, that means that x1 will equal x2. So I'm going to solve. But what happens when I set these equal to each other, I find that I have 2 variables in here. So simplifying, or rearranging this, I should say, 3t minus m equals 3. So I'm going to get it in this form. So I have an expression using the scalar multiples from the direction value, or the direction vector. I'm going to do the same with the y's. So y1 equals y2. 7 plus 7t equals 1 minus 2m. So 7t plus 2m equals negative 6. I'm going to take those 2 equations and I'm going to solve for t and m. and you're going to use, it's just grade 10 math all over again here. So 3t minus m equals 3. 7t plus 2m equals negative 6. So you're going to use elimination. You could use matrices here, but we both agreed in the matrices lesson, it's much, much easier with two equations, two unknowns, to use elimination. It's still the best method. I'm going to double that top equation. So 6t minus 2m equals 6. 7t plus 2m equals negative 6. The signs are opposite, so I'm going to have to add. So 6 plus 7 gives me 13t plus 0m equals 6, take away 6 is 0. So therefore, t is equal to 0. Now we've got to solve for m. And the reason, do we really need to solve for m at this point? I'm thinking more the 3D. It's not really a requirement at this point because it's two space. So if they're going to intersect, we're going to get a solution. So what I'll do is I'll show you the what if. So therefore, if t equals 0, then from above, using the top equation, so what do we got? 1737. So xy equals 17 plus t 37, and I substitute t in. Therefore, they intersect at 17. What I was worried if you get no solution, what would happen in a parallel universe here? You would have ended up with 0t equals 0, right? Or, in this case, there would have been a solution. There'd be infinite solutions here, because you can plug in any value of t here, so you'd have infinite solutions. If you would have ended up with 0t equals 5, there'd be no solution. So that's what it would have looked like for the other two options here. So with two space, skew was not one of the options. It was either going to intersect, or it was going to be parallel. So this is your parallel. Or it was going to be coincident, or the same line. All right. So two space is not going to be something, you're not going to see it on a test. It's just sort of a starting or jump off point for us in this particular lesson. So, can I get through one more? Easily. Okay, so 3D examples, more what we're going to be looking at here. So, going through this, again, I don't like symmetric form for this particular process. So I'm going to write it out again. x1 equals negative 5 plus 3t. y1 equals 2 plus 2t. And now z1 equals negative 7 plus 6t. Over here, x2 equals m. And that's because it's being divided by 1. So it'd be x minus 0 and then 1m. Okay. y2 is equal to negative 6 minus 5m. All hung up on my t's now, 5m. And z2 equals negative 3 minus m. It's the exact same process with one little twist, and we'll talk about the twist in a second. So you can compare whichever one you want. Again, I just run with the x's. So x1 versus x2. So negative 5 plus 3t equals m, which would mean I'd have 3t minus m equals 5. So there's one expression. I'll look at my y terms, and you can pick your z's if you think it's quicker or easier. It does not matter. So simplifying that, 2t plus 5m equals negative 8. I'm going to stack them on top of each other. I'm going to solve. And what I'm going to do, I'm going to, maybe for this one, I'll just write it out. I was going to multiply the one equation to save myself a bit of writing, but for this purpose, you can see that shortcut yourself. So this one, I'm going to multiply this equation by 5. So normally I would have multiplied it by 5 when I wrote it out. Save me a step. But you're all students that find shortcuts on your own, so I'm not going to insult you by doing it for you. There we go. So getting rid of it, again, the m's, the sign's the opposite, so you should be comfortable from this Going back to grade 10, and 25, take away 8. That gives us approximately 17 as well. So that's good. So t does equal 1. Now in this case, we do have to find the second value. We do have to find the m. So you have to continue using the one of the equations from above. So I'm going to use this equation here to find m. So if t equals 1, then 3t minus m equals 5, minus m equals 5. So we'd have 3, well, doing this is in a ton of steps apparently. Anyway, you get m equals -2. All right. So according to this, right now, it says that the line crosses because we found a value for m, we found a value for t. In 3 space, you have to do the check up here. So for 3 space, you must check the third coordinate. Okay. An absolute must here, because it's the one that determines if the lines actually cross. So from the above, you find that Z1 equals Z2. So when you go through and do the check, and there's a couple ways to do this. You can just actually, let's not simplify or solve that. Let's just go with Z1 equals -7 plus 6t. So -7 plus 6 times our t value is 1. So we end up with -7 plus 6. So that means we end up with Z1 is -1. Z2 is equal to -3 take away m. So -3 take away -2. So that's like adding. It's -1. Therefore, Z1 equals Z2. So what that tells you, therefore the lines cross or intersect. Let's intersect. All right. So the proof is a must. You absolutely have to do the proof. Now you can take one of the 2 equations, doesn't matter, and you plug in your value. I'm going to use the one with the t because t equals 1 is the best one to use here. So I'm going to take that expression there, and I'm going to clone it, and I'll move it down below just because I can and cheat like crazy here with the smartboard. So if t equals 1, and I have this expression right here, therefore the point of intersection, my x value will be -5 plus 3. My t value will be 2 plus 2 is 4. My z value will be -7 plus 6, which gives me -1. So there is the point in 3 space where these 2 lines will intersect each other. All right. So the check is an absolute. You must do that check to make sure it does actually intersect. I believe that's it for this lesson. No, I have one more example here. I will finish that up in the next quick video. It won't be a very long one.